It could be a quarantine get turned occasionally. I gotta get a haircut this weekend. My hair's getting crazy long. Ben, you need to solve a mystery for us.
Uh-oh.
All right, the girls are going to talk to you.
Okay.
We saw your sister in the halls.
Oh, that. There's a little. So, because in science there's something called a lab, we sometimes have to go in. I unfortunately was unavailable at the lab. You guys did. I think you did a lab.
Because you couldn't actually find your clothes.
No, I'm wearing
in your pajamas for the last 2 months.
Actually, no, I haven't been doing that. It's really weird. That's what my siblings have been doing. Thankfully, nobody's in the room.
Oh, first couple weeks you were in your school uniform.
Yeah, I still am.
You still are?
Yes, except my laptop has no camera, so I'm sorry.
Okay.
Why are you wearing your school clothes, baby?
No, he's going above and beyond. He's not making excuses.
I was up every morning. I would just turn off my camera. Yeah.
You could do Mr. Graham, just put a piece of tape over it. He was always like, oh, the NSA is spying on me. And I was like, yeah, probably not.
Here, one sec. I'm pulling up Zoom on my phone. I have to type in the thing because I don't have the link.
He's going to prove to us he's in his school uniform, not his pajamas.
Yeah. No, I just want to do it because I want to see the look on your faces, even though I can't.
Oh, we've already seen you a couple times.
You can't see the look on our faces. It's when Mr.
I know, that's why I just said I can't.
Yeah, anyways.
Is there some kind of ice going on outside?
Yes.
But they were late.
All right, hi. Why are you by the wall, Jack?
Oh, sorry, I'm solving a Rubik's Cube.
Oh, okay, good for you. Gotta make sure I get this right. All right, that is it. I'm in.
There's 2 Bens, huh? The world's ending.
No, it's not.
So if I throw this at the window, will it break or will it not?
Not sure if that's disturbing or comforting.
Who?
You. The fact
Why?
that you had to show us all your clothes.
All I did was this.
I got you. All right, let's do some geometry.
Now you have 2 of me.
Is this technically a form? Can I use geometry to solve these things? Or no?
All right, have a seat. Get out your homework.
Jack, I don't know this English. English homework tonight. Science not homework tonight.
All right, any questions?
If I add 3 numbers together, will I get a bigger number?
Not if 2 of them are negative.
Oh, really?
Yes.
Just the last reason on.
Yes, I'm happy.
On number what?
17 proof.
Proof. What'd you have?
For the reasons I had given and then theorem.
No, I meant the last one.
Oh, I didn't get any.
Oh no, I thought you meant literally the last step of it. All right. So this you got 2 triangles that kind of make the hourglass, and you're told that things are perpendicular. Well, clearly the measure angle 2 is equal to 90, and the measure angle, measure angle S is equal to 90, and the measure angle T would be equal to 90. Why?
Wait, which question?
Definition of 17. Definition of perpendicular lines.
Oh, I have Kona eyes.
We're already past that. And then angle S is congruent to angle T. Y, definition of congruent angles, right? Or definition of congruence. No, definition of congruent angles, right? Angles that have the same measurements. And then see, B is the midpoint of ST. I don't like it the way they do this proof because they split the given up. But that's also part of the given. And then SV is congruent to VT because of
Congruent.
definition of
a
midpoint. Right.
Yes, I failed at that.
And then RVS, UVT. This is kind of what we did yesterday in class. Didn't we do this yesterday in class? Like I pulled this up as an example.
My U's look like that.
And those two angles are vertical, so vertical angles are congruent. And then lastly, so the last step will be once you figure out, I'm trying to roughly draw it. It's something like this, where you just showed that, let me make sure I get the right thing. So this is horrible. It needs to be like this. There we go. So that's right, this is congruent, and then this was the midpoint of this, so you got that's congruent to that. So what's the reason?
ASA.
ASA. All right, anybody else?
Nope.
All right, here we go.
Class.
Number one, now I'm not going to call out the congruency statement because you may have written it different the way I wrote it or the book wrote it for the answer. I'm just going to call out the reason. ASA for number one. Number two is SAS. Number three is SSS. Number four is SAS. Number five is, well, they're just two isosceles triangles, but we can't say anything about their angles, so we got nothing for that one. Number six, it looks like we have, with the reflexive property, we'd have ASS, so that doesn't work. Number seven is SAS. Number eight is another ASS with the vertical angles there. That doesn't work.
What's 7 again?
7 is SAS, but 8 is nothing. Now, if they don't say they're not congruent, right, they just say that we can't deduce that they're congruent from what we're given. Number 9 is ASA. So is number 10. So is number 11. They're all 9 through 11 are ASA. Number 12, you could get alternate interior angles. You could get vertical. That would give you angle, but you can't say anything about the sides, so you get nothing for number 12.
Yay.
Number 13, let's see. We could certainly get two sides and an angle, so we would get an ASS. Is that right? Could we get an angle for that? Yes, we would. We would get, let me check, make sure. That would be SAS. Oh, on the triangle on the right, we could get SAS, but the triangle on the left would be ASS, and that doesn't work. 14 is SAS, though, and 15 is ASA. And the proof should go given, reflexive, given, and then let's see, BAC, DCA, BAC. That's
Alternate interior angles.
Alternate interior, and then finally SAS. And then on 17, we just talked about it. Given, definition of perpendicular lines, definition of congruent angles, given, definition of midpoint, vertical angles are congruent, and then ASA. All right, so let's see, 18. I gotta see if I can prove this. Let's see, TM.
Can you turn to the screen so I can see what you write down?
I'm not writing down anything, I'm trying to do it in my head. Let's see, TM and PR, TM parallel, so that gives us side, oh, vertical angles. TM is that side, so that would give me, which are parallel?
Parallel TM and RP.
So that would give me angle T and angle P are alternate interior. It's going to give me AAS.
No. The ASA.
I'm not reading it right.
You already know
TM
one,
and
and then you
PR.
get vertical angles, and then you get alternate.
I got to draw this sucker. You're given that. You're given that TM and these are parallel. They're parallel, then that means this angle is congruent. Oh, but then
Wait,
this one is
oh.
this one as well.
Wait, tick mark.
ASA,
Not
ASA,
Tick, not tick mark. Wait, oh, there are.
ASA, ASA.
That's right.
I was thinking you need to use the vertical angles and you don't.
I mean, you could do AAA.
There is no such thing.
Oh, right, of course.
Okay, so I mean, it would be basically 2 steps, or 3 steps.
Wait,
So
I
you
did
get
it with-
alternate interior angles.
I did it with vertical angles.
You got to tell me what you're claiming then.
Oh wait, no, I did it wrong because then
Okay.
it would be
It would be AAS. Oh, by the way, we get that one tomorrow. So you could actually, but we don't have it yet. All right. And then 19, it's the same thing except E is the midpoint. So we would get that this midpoint of TP. So we get that and that. This is 19. And E is the midpoint. And then you get this and this. And then vertical angles, so SAS. That would be the proof. Ben, questions on that?
Can you go over 18 one more time, real quickly?
Yeah. So we would make a statement, something like angle T is congruent to angle P because of alternate interior angles. Then we would say angle R is congruent to angle M. I'd probably make that just one statement because it's the same reason for both. Alternate interior angles. When that would give us ASA. So that's like one step with the given, or 3 steps with the given and the ending statement. So that was easy.
Okay. What about 19?
If it's the midpoint, then you get TE is congruent to PE and ME is congruent to RE, one statement, definition of midpoint. Then vertical angles are congruent, and then that'll give us SAS.
Okay.
Cool?
Yes.
Let me swap. I'll give you something, and you'll give me something.
Money?
Oh, yeah, let's do that. I'll give you $1, you give me 5.
No, that's horrible. That's a horrible deal. That doesn't sound like a pyramid scheme to me at all.
What's a pyramid scheme?
It's when there's one person on top, then he recruits other people who recruit more, who end up giving the top person more
And
money.
you get something called,
A pimp.
you get something called nonlinear growth. So nonlinear growth is good because you're not doubling it each time. You know, it's exponential growth, right? Especially if you, well, let's do a pyramid real quick. So you start off with one person, which breaks off into 2, and then this person recruits. Even if we just say they recruit 2, and this
What's a
person
pyramid
recruits,
scheme?
that's what we're doing. So this is really 2 to the x. That's the growth factor right there. So depending upon which row you're on, if we're on the first row to the first, second row to the second, third row to the third, right? It's pretty cool growth.
But yeah, is it illegal? Kind of like.
Oh, it is illegal.
Okay.
It is illegal.
Like cults.
Well,
do that.
there's nothing wrong with that structure. I don't know if you heard of this company called Amway. There's lots of companies that have this model. What makes a pyramid scheme illegal is that here's what the scheme goes. It goes something like this. This is me. If you give me $10, in 2 months I'll give you 100. Who wouldn't take that deal? The issue is that I'm not actually selling anything. I'm not making any money. What I'm doing is, well, then you're going to recruit 2 people, and you're going to say to them, you give me $10, and in a month I'll give you $100. What happens is that you give me that money at $20. And what I do is, and I've got a bunch of people doing this for me, what I do is I pay you $100 out of the money that I'm collecting. And if you get hundreds of people to do this, you're raking in millions of dollars. And then you're paying that money out. But it's called a pyramid scheme because eventually it collapses because no one is actually making anything, right? I'm not selling anything. I'm not creating anything. All I'm doing is taking money that people give to me and handing it back out and making a crazy promise like you give me 10, I'll give you 100. And that's what makes it illegal. But an actual, it has a name to it. I'm not an economist, but it has a name that where it's not called direct marketing. It's called something like that, direct selling, or I don't know.
But if you're not selling, but how is it illegal? You're just tricking a bunch.
You're tricking a bunch of people. So
Okay.
the classic, the recent one was a guy named Bernie Madoff. And Bernie Madoff said that he was a smart investor. And if you gave him your money, he would invest your money and he would give you a crazy good return on your money, which he did to a few people below the top. But everybody on the bottom was giving these promises that they were going to get this money back. And what he was doing was he was taking all the money of the little people, giving it to the people on the top of the pyramid. So the people on the top of the pyramid who were recruiting the people on the bottom were very happy. They're like, oh yeah, Madoff's made me a lot of money. Look at my bank account. See, he paid me all this money. people on the bottom weren't getting any money. It was all fake. And that's why he's right now sitting in jail. I mean, he stole, I don't want to say it was definitely not millions. I don't know if it was close to $1 billion, but I mean, we'll look it up here at the end of class. He stole lots of money.
So is it kind of like a cult? How they
Yes, it is exactly like that.
All right.
Right. All right. And it never ends. I mean, you get these pyramid schemes all the time because people want to believe that other people are smart enough to make the money, or they want to get something for nothing. Okay, so we'll do this real quick. This won't take too long. I don't anticipate maybe in this class that we would have another review, but we'll see how it goes. We'll see how it goes. All right, so just recall yesterday's class, we were basically, the big idea was I give you 2 triangles, and you tell me that the 2 triangles are congruent. The way we do that is, well, we still have this method number 1, and that goes by the definition of congruent figures, which is congruent figures have corresponding sides and corresponding angles that are congruent. So if you want to prove that 2 triangles are congruent using that basic definition, then you got to do 6 things. You got to show that all 3 sides are congruent, all 3 angles are congruent. That's a lot of work. Luckily for us, there are shortcut methods. The first one was called SSS. It's either shown either in diagrams where all 3 sides are congruent to all 3 sides, or they could use numbers, or a combination of both. Also remember the weird one that looks like this. What gives us side, side, side from this picture?
SAS. I mean SSA.
What?
SAS.
Yeah, one of the sides of the triangle is shared in both triangles, so that we can say reflexive property for that 3rd side. And you're going to see this is a very common thing that we do a lot. And then the easy one where they're literally just separated from each other. You better not make a mistake on that one right there. All right, the second one was SAS, and I just want to point this out. You got to check both triangles. Just because the one on the left is SAS doesn't mean the one on the right is SAS. If the one on the right is ASA, even though ASA is one of our options, they both have to have exactly the same congruency tick marks. Meaning that if one is SAS, the other one has to be SAS. If one of them is side, 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 and the other one isn't, well, then you can't claim that that they're congruent. All right, SAS or not SAS?
Yes,
Why?
because there's 2 little tick marks on the side.
So that just gives me side angle. Where's the other side come from?
Because they're parallel to each other.
Where do you see parallel?
Well, it would clearly be parallel.
Where do you see parallel? What's parallel?
All the sides of the triangle to the left.
What? Show me with your fingers what parallel means.
It means they're.
Show me with your fingers.
Oh no, they're not parallel. They're congruent. That's what I meant.
Okay. Where do we get that the other sides are congruent?
By congruent angles.
Well, we're given only one congruent angle.
But
Why is this one SAS? Do you see what's in red, McKinley?
Yes.
Now look at one of the triangles and read what it says in red. Is this a side or an angle?
This is an angle. It's a side.
Okay, so I got side, read.
It's the 2 sides.
No. I'm saying this picture on the screen right now. Side,
It's good. Sure.
side, angle, nothing else is marked. So are those 2 triangles congruent?
Yes.
Well, how?
Because they both have side angles on them.
They both have what?
Side angles.
Yeah, so all I have right now is SA. There's 2 options. I either need to show another angle or I need to show another side.
Well, there is another side.
Where?
Below the.
Why is that congruent?
Because they equal the same amount.
Why?
Because of the 2 tick marks that show that.
There's
they're
no
equal.
tick marks here.
No, I was talking about the one below.
Yeah, so that just means this one is congruent to this one.
Yeah.
We got to have 3 things. Either SSS, ASA, or SAS.
Well, it had to be ASA
Well, where are you getting the other angle from?
because it's right below.
That's only one. I'm looking at one triangle at the top. How many red parts are there right now?
2.
You gotta have 3.
So it can't be.
Okay, it turns out what this one is. Go ahead, Jack, tell them.
It's SAS because they share one side.
Notice that both triangles, if I draw them separated from each other like this, both triangles share this side. It's the same side. Well, clearly it's got to be congruent to itself, right? If it's the same one. So that's my third side. So I got SAS. You only got to look at one triangle, not both at the same time. One triangle and read what it says. And remember, SAS is the included side. It's not that you have 2 sides and an angle, but it's got to be 2 sides and the middle angle, which I said yesterday, except they don't call it middle. They call it the included angle. SAS. Back to you, McKinley. Are they congruent or not congruent?
Yes.
Why?
It's 2 sides.
That's only 2 sides.
Well, they're connected to 2 sides together by 1, which means they have to be congruent to both sides.
The only way we have is either SSS, SAS, or ASA. If they're congruent, then you got to tell me it's one of these.
Yeah, it's SAS.
Why?
Because the two triangles connect at 1 point, and those points have to be congruent to each other.
What do you mean points have to be congruent?
The 2 tips of the triangle.
Okay, that's a
I don't know how to
point.
word this.
I know you don't, so I'm making you struggle here. What are you trying to say is congruent?
The intersecting point of both triangles.
The intersecting point?
The intersected angle.
What do you call those angles?
The tips of the triangle.
Draw what you think are congruent. And then we'll help you with the words. But we want to make sure that you're telling which things are congruent. Okay, so when you put a tick mark, tick marks are exclusive for sides, arcs are congruent for
It
angles.
would have to be this,
Yes. So why is that true?
because they're angles.
Why is it true? By the way, you're right, but why? Why are those 2 angles congruent?
Because they're on the very end, and they have to be congruent to each other.
No, they don't. Watch this. Is this congruent to that?
No,
Why?
because the angles don't match.
Well, I could make the match.
Because they're not directly across from each other.
And we call those type of angles, not opposite angles, we call them,
Same side angles.
no, vertical angles. I keep giving you everything. All right, so why are those 2 triangles congruent?
Because they're angle side angle.
Where angle side angle has 2 A's, which
Side angle side.
side angle side. Are you with me or not with me?
I'm with you.
Okay.
I just don't know all the words.
All right. Why are these 2 triangles congruent? Or are they congruent?
They're angles. They don't match.
Why are those 2 congruent?
Because the 2 bottom parts are equal.
Great, I got a side. I got 1 letter. I need 3 letters.
Well, you do have 3 letters.
What? Which 3 letters?
SAS.
Where's the other S come from?
From that one, which has the 2 little tick marks.
That's 1.
But then you have the angle.
Then
one
there's an A. So I got an S and an A. Where's the other S come from?
from the bottom.
What do you mean the bottom? You can't go from this triangle to this triangle.
Well, not that part, but the kind of intersecting part of both triangles that you can put tick
Because
marks, it's
Because
the same side.
Because
they're same side sides.
letter R. Because they are
Vertical.
You
don't know.
reflexive. Reflexive means that A equals A, or A is congruent to A. So we can say that this dark line right here in the middle is congruent to itself. That will be our second, I'll put 1 tick mark, side angle side. Yes or no?
Yes.
You're going to see this a lot. See this a lot. You got to be able to say reflexive. All right, and the last one we have is ASA. Just make sure it truly is ASA. That means 2 angles and the included side, or the between side. The side that's between the 2 angles. It can't just be an A, an S, and an A. It's got to be 2 angles and the included side. Are you afraid that I'll pick on you or no?
No.
Or you're like, well, pick on me, I got this.
Yeah, pick on me. Go ahead.
Yes or no? McKinley,
What? Yeah.
are you afraid that I'll pick on you?
Well, I
Or
didn't
you're like, I
spend-
got this?
I spent half the class gone. I'm still catching up a little bit.
Yeah,
You were
wasn't
here
for
yesterday.
ASA.
Yeah, for only half of it.
You left for an orthodontist appointment.
Yeah.
Yeah, but you left after I thought we did.
No, we only got to postulate 13.
Okay, so here you go. Write this one down in your book of truth then.
I've already written down that book there.
Okay, cool. It's the same one. All right, cool. So, McKinley, why are these two triangles congruent?
Because they have all the same tick marks as
3 ways to say it.
are congruent to 2 angles.
No. SSS, SAS,
ASA.
ASA. Which one is this one?
ASA. Because the angle side, they all match
No,
up.
3 letters, not 4 letters.
ASA.
Okay, do you see an ASA up there?
Yes.
Okay, that's true, because it is. How about this one?
That's not ASA. There is not another angle. If anything, it would be SAA. SAS. Sa.
Look at it.
No, it could be ASA because you can put angles on the tips of the.
Not tips.
The angle, I don't know what those are.
Letter
Vertical
V,
angles.
vertical angles. All right, so what is this one?
This is ASA.
ASA. All right. These are the, we're going to get a couple more, but as of right now, this is all we got. SSS, SAS, and ASA. All right, McKinley. Letter combinations here, right? S's and A's. We don't have 2 of them. The 2 that we do not have, well, here's your first one. You see this triangle?
Yes.
You see the angle that's marked with blue?
Yes.
Okay, does it have a number next to it? It's saying it could be anything. So if I look at what I have, I've got side, a side, and an angle. If I make another triangle just like that, you see what I did? The side is 6, that side is 6. The side is 11, that side is 11. This angle is 30 degrees, this angle is 30 degrees. Notice I don't have any measurement for this third side. It could be anything. If we have this as being 6, do you see how it could rotate? Because I'm not claiming that that angle is congruent. It could rotate and it could hit this triangle in 2 different spots, here and here. You'd wind up with 2 completely different triangles, right? A small one and a big one.
It would have to be the big one.
No. I'm saying it could be either one. So in this construction of SSA, you don't get 1 triangle, you get 2 possible triangles. So therefore, you cannot state that you have an SSA ever, right? SSA, I shouldn't say that. SSA on this type of triangle, you don't get, okay? This is called,
Now we have the annoying donkey.
right, so this is called the donkey one because if you spell it backwards. Get it? McKinley? Okay. All right. You also don't have AAA, and this is the reason why. Here's one where all 3 angles are 60. Here's another one where all 3 angles, it's an equal angular triangle, and clearly these 2 triangles are not the same. So you don't have an SSA, you don't have an AAA. Lastly, you got to look at both triangles. It doesn't matter that the first triangle is SAS. If the second one isn't SAS, then they're not congruent. So this is what you missed, McKinley. Try this one out. You see this first group right here?
Yes,
Why are these 2 triangles congruent?
because they're the same.
Tell me why.
Because they're angle side.
3, because they're what?
Because they're ASA.
They are ASA. Both of them?
Yes,
Okay. How about the second one?
that is SAS,
Where do you see an A?
not SAS. SSS.
Why? Where's the third S?
In between the middle of
Because of letter R,
reflexive.
reflexive property. Okay. How about the last one?
That is
Or I should say the 6th one.
SAS.
Where's the A from?
Because the 2 angle, the vertical part.
Whoa! You did it without any prompting. Very good. How about this one?
Yeah, that's also SAA.
Where do you see SAA?
Because it has 2 sides and an angle.
Well, SAA is SAA, not 2 sides and an angle.
SAS.
Where do you, yeah. You see how you can look at this and say it's SAS? If we read SAS, here's an SAS, SAS. It also reads the same thing backwards, SAS. Okay, this reads SAS as well too, but if you start from the angle, it doesn't say that, it says ASS.
So,
Remember, the definition of SAS is two sides and the angle between them. So if this one was SAS, then it wouldn't be this angle that's red, it would be this angle right there. This would be SAS. Two sides and the included angle, the angle in between. So this one is actually, what's this one, McKinley?
that is actually SAS as well.
That one's SAS, isn't it?
No, the other one is also, no, wait, no, other one isn't. It could be ASS.
That's right. You getting tired of
We
that?
got rid of all of the answers in the top one.
Oh yeah, you gotta fix that. How about the last one, McKinley?
That is, yeah, that's SAS as well. There is, both sides can be SAS.
I'm looking at the bottom, and I clearly have an SAS.
Yeah,
What about the top?
SAS,
Where do you see that?
because it can go that way, and if it goes up.
So the
and up-
definition of SAS are two sides and the angle between. Two sides and the angle between. So here's the side, here's the side. Where's the angle between?
Oh.
Right there. This one is another. I will do it one more time and stop. All right, that's enough of
More
that.
answers on that one either.
All right. Okay. And the last two things that you've already seen on the worksheet if you're working ahead is that I'm going to give you two triangles. You have to write a congruency statement. Okay, so McKinley, give me a congruency statement.
They're congruent.
Now, we know that they're congruent. Now give me the congruency statement.
You asked me to do the.
You need to tell me
BAC.
that thing. Congruent, not equality.
I
So
mean, congruent to FG.
give me the letters.
BAC. is
So
congruent-
triangle BAC is congruent to triangle.
The opposite of that, FGH. Triangle FGH.
You got it.
Okay.
Question on that? All right, this one's a little bit more tricky.
Can we be done with the
Well, if you do this one, we will be done.
Angle ZX.
Give it to me.
Angle ZXY is congruent.
All right, let McKinley do it.
Here, CXY is equal to.
ZXY, so triangle, don't forget triangle, so ZXY, so he's going right to left.
ZEY. Triangle ZEY.
Is he right?
No, it's
No.
Y.
Z goes with,
Y. Oh yeah, so it's Y.
X goes with,
E Z. Y E Z.
to spell anything?
Zixi equals
Easy, I can see an easy,
Zixies.
Xerxes.
Xerxes.
Xerxes, I don't know. Okay. All right, that's it.
Cool.
Did they crank down your teeth yesterday?
No.
No?
I just got my bands off.
Oh, feel better?
Wait, but
Yes.
AAS would work.
We gotta prove it, but yes.
Wait, so the donkey will return?
No.
No.
I mean, yes, it will. No!
I have 30 seconds of it.
Don't do it, please. Please no, please no.
Why isn't he not talking? Talk, donkey! Be thankful. It was a 30-second clip that I
Something
shortened.
is in pain.
Yeah, what happened?
I've never owned a donkey, but that's what donkeys sound like.
No, I thought they sound like it's Shrek.
It looks like he's happy.
No, it doesn't. It looks like he has a broken jaw.
Yeah.
What donkeys look
I know.
like.
Still though, it looks like he has a
Are
broken
you
jaw.
sure? Let's turn to the internet.
Yeah, we won't be doing that.
No? Why? Because something will happen on the internet? Or
Yes, bad things.
bad thing?
That thing has to be figured.
You don't know that. You can find knowledge on the internet.
Yeah, but you can also find anything on the internet.
Yeah, there's something called, I forget what it's called, an internet rule of some sort that says that you can find anything on the internet no matter what you type. I mean, like, you can't type anything into the internet and not find something.
Even if you type like puppies down, you still find something to search.
Yeah, exactly. That's why I rarely do what was I going to show you?
Oh yes, the guy who got arrested for doing the pyramid scheme.
Oh yeah, Bernie Madoff.
I did not. I can make myself one.
It's unsolvable now. Yeah, it's unsolvable.
Useless. Mix it up.
Pyramid scheme is also called a Ponzi scheme, but that's what it means. It's not Ponzi is not Latin for pyramid or anything like that, but it was named after like somebody who first came up with it.
Kind of a genius idea.
Americans are taking to the streets in anger for ruining the economy, and CEOs for taking bailout money as bonuses at the stock market for demolishing their retirement plans. Into this arena.
Hold on. Ben, you have any questions? We're kind of done right here.
No questions.
Okay, I'm going to end the video now.
Okay, goodbye.